All right, so welcome folks to the main presentation for the meeting. Tonight, I'm going to be handing the mic over to Hunter Young, EPA Region 10's Remedial Project Manager, very shortly to introduce Bob Wyatt from Northwest Natural, who's going to be presenting on treatment instead of capping at the Gasco Sediments site. So to set this up on the process side, we have about 40 minutes for this topic, 20 minutes for presentation, about 20 minutes for questions. And we're going to ask that people hold their questions until the end of the presentation so that we can fully record Bob's presentation segment. But feel free in the meantime, while he's giving the presentation, pop your questions in the chat. You can raise your hand. I'll get you in the queue and I'll take the questions as they're received, as long as they're related to the treatment topic. So with that, I'll go ahead and introduce Hunter Young to go ahead and kick us off.
Hi, everyone. As Annie mentioned, I'm Hunter. I'm a project manager for EPA. I'm excited to introduce this presentation today by Northwest Natural. EPA has been working with Northwest Natural toward the cleanup of the Gasco project area for several years. Last year, Northwest Natural submitted a draft preliminary design report that EPA had a lot of questions, comments on. Now, Northwest Natural has taken those comments to heart and has brought us something new, a new concept, which will address the contamination in their project area that EPA is supportive of and moving forward with. I want to emphasize that this is a concept, and there's many technical evaluations and discussions that we still haven't had yet and will be had in the future. That being said, we've often heard from the community that they would like to be engaged early and meaningfully. This presentation today is our effort to meet that request. But just please keep in mind that there's a lot of details yet to be ironed out. We're just bringing to you a concept early in the process that over here at EPA we're excited about. So without further ado, I'll hand it over to Bob and you can jump into the presentation.
Thanks very much, Hunter, and hi, everybody. I am excited to be here. Everybody who knows me knows that I've been working on this site for over 20 years, and it's quite a time commitment for me. It's been a privilege and an honor to work towards cleaning up the river. And tonight I'm going to be talking to you about something that's very exciting to me personally and to the Northwest Natural Gas Company as a corporate priority, which is cleaning up the Gasco site and the design for that. So without further ado, I'm going to launch into the next slides. So next slide, please. So tonight what I'm going to talk about is a little bit of the history of Gasco. And then I'm going to talk about the treatment technology that we have brought to EPA for consideration, what it is, where it's used, and why we're considering it for the Gasco site itself. I'm going to provide a summary of why we think treatment is a better method to clean up the site from an environmental protection perspective. We believe it's going to be a more protective cleanup using treatment instead of capping at Gasco. And then I'm going to show you what it would look like if we were to do this at Gasco. Next slide. So this is the Gasco site. Many folks are familiar with it. If you look at the picture on the left-hand side of your screen, the Gasco site is right about in the middle of the Portland Harbor Superfund site, around River Mile 6, and it's on the west side of the river. It used to be a manufactured gas plant. That's where we created gas instead of getting it naturally from the ground. It resulted in contamination both in the uplands and in the sediments. We've been working on it for quite some time. So you can see the milestones listed here that I thought were relevant to tonight's presentation. In 2000, EPA listed the Superfund site. In 2005, Northwest Natural did the first early action in Portland Harbor, which was dredging of a tar layer that was visible from the shore. In 2009, shortly after that effort, we went to EPA and recommended an agreement where we would start design early, ahead of the record of decision for the Gasco site. And so EPA agreed with that. We entered in order to do that work. And in 2012, we submitted a document that provided alternatives that could address the cleanup for Gasco. EPA evaluated those concurrently with looking at all of the data from the feasibility study for the entire Superfund site, and ultimately issued the ROD in 2017. After the ROD was issued, Northwest Natural immediately went to EPA and said, okay, let's move back into the design conversations. And we did. And in 2021, just last year, we submitted the design for Gasco, a preliminary design, and it reflected what the record of decision identified as the uh, template technology for Portland Harbor, which was dredging and capping. We received a number of comments from EPA on that design, and many of them were associated with expanding the amount of dredging to remove more material. But we saw some limits to our ability to accomplish that with dredging and capping, and we're evaluating other methods, and treatment came out as a very good alternative. And so we proposed that to EPA earlier this year, and as Hunter said, EPA was receptive to that comment, and we have now been working with EPA on how we would apply it to the Gasco site. So next slide, please. So the treatment uses a technology called in situ stabilization and solidification. Next slide. So what is ISS? That's the acronym for In situ stabilization and solidification. It's a technology where we mix material into the sediments in place, and it creates a permanent and stable treatment solution. This has been used in a number of different places. I'm going to talk about that a little more later in the presentation. But you can see in the images here that we use these large diameter augers. They're about 8 to 10 feet around, depending on what vendor you use. And the material that is mixed into the sediments gets injected through nozzles at the base of these mixing units. And then the mixing unit is sent down into the sediments and blends all of the treatment materials with the sediments. And once the blending is completed, the materials and the chemicals in them have been solidified and stabilized, so the contamination is no longer released. Next slide, please. ISS has been in use for quite a long time. It's typically used at places where long-term and permanent solutions are sought. It's a common technology at manufactured gas plant sites around the country. So the materials that we have at the Gasco site are particularly well suited to this type of treatment. It's been tested many, many times. Dozens of manufactured gas plants with soil and groundwater impacts. It's been used at sites that are managed by state programs, multiple federal regulatory programs, and it's also been used at Superfund sites. Some examples are the Gowanus Canal site in Region 2 and the Wyckoff site up in Region 10, and dozens and dozens of MGP sites in the US. It's also been used overseas in Australia and Europe. And typically it gets used where you can't reach all the contamination with traditional technologies, which is what we have at Gasco. Next slide, please. So there are 6 main reasons why we're looking at this treatment technology for Gasco. There are actually others, but these are the primary ones that I wanted to talk about tonight. When we got EPA's comments and they asked us to dredge deeper and dredge more of the material, we started to look at what we would encounter in terms of engineering design challenges. And if you look at the image on your left-hand side of the screen, you can see a configuration that would represent how we would cap this site. The lower line that has churros, and I'm sorry for the small font, and I know it's difficult to read, but the lowest line under the image, if you can move the cursor to the left a little bit. I'm sorry, on the left side of the image. Yes, exactly. There's a tan line at the base of the figure, and that's the depth of contamination at the site. This is a cross-section view. And the blue area that's hatched represents the amount of material that could be dredged and then subsequently capped after the dredging is complete. And you can see as you move from the shoreline, which is on the left-hand side of that figure, to the river and the navigation channel on the right-hand side, the slope gets very steep, and it's very difficult to maintain slope stability at that portion of the site. And it's also difficult to maintain the structural stability of the dock. And so you can see a sheet pile wall that's described there. that would be needed to support the bank to keep it from collapsing into the navigation channel. To support that sheet pile wall, a rock berm would have to be installed, and then the cap could be placed behind the sheet wall towards the shoreline and create a stable slope for the long term. And slopes like that, are definitely constructible, and we could do this project this way, but it would have a little less seismic stability than the approach that I'm going to be talking about later. And it also leaves quite a bit of contamination buried, which gets managed through capping. The cap prevents contamination from reaching the receptors, so it's a protective remedy, but we can't remove all the chemistry. If you look on the right-hand side picture, the orange zones represent areas where we have very high concentrations of chemicals. Some of it is oils and tars. The dashed line that you see in white represents where the navigation channel location. The yellow line represents the transition between what the ROD calls the intermediate zone, which is a depth of water below the shallow zone and not quite as deep as the navigation channel. Shoreward of that yellow line is the intermediate zone, the shallow zone. So it goes from navigation channel to intermediate to shallow. And then there's the riverbank. And so you can see we have these high concentration pockets scattered both in the shallow, the intermediate, and the navigation channel areas. And so we have to address all of that. The original design addressed it through dredging and capping. The design we're going to talk about tonight uses the treatment method instead. Next slide, please. So the ISS approach can treat all EPA concentrations that were established in the record of decision. Those are known as the RALs, or the remedial action levels. And so we cannot dredge all of the contamination to action levels, but we can treat it to action levels. It is a permanent treatment method. It actually minimizes the disturbances and releases that can occur during dredging. Everybody knows that when you dredge, you scoop material out of the bottom, you lift it up through the water column, you place it on a barge and carry that barge away for disposal. And so there's a lot of material that gets moved up and down through the water column and then transported. And so when we treat in place, we minimize the amount of material that gets pulled through the water column. And we also reduce the amount of material that gets removed and requires trucking. It also leaves behind a material that has structural stability. And so it's more stable in seismic activity. And so the figure that you see here is just a visualization of what the ISS approach would look like in cross section. So basically everything from the riverbank on the left-hand side of the screen, all the way out past the docks to the edge of the navigation channel would be treated in place to action levels. And then everything that's contaminated past that in the navigation channel, we would fully dredge. So we are dredging material from the navigation channel. We have to do that in order to meet the depth requirements for navigation purposes. But we also want to remove it all so we don't have to put caps back. So once this remedy is complete, the idea is that there won't be any exceedances of those action level chemical concentrations. Next slide, please. The next slide, I'm going to talk about the kind of comparison between the dredge and cap alternative and the ISS alternative. Next slide, please. So when we look at dredging and capping, we look at the dredge opportunities we have, and we can only technically reach about 70% of the high concentration material. With the ISS, as I was saying before, we can treat 100% of that high concentration material. Back on the left, the second bullet, we do have groundwater that's contaminated. We are managing that with DEQ in the uplands using a source control system. But when we have contaminated sediments left behind under a cap, that contamination can be mobilized by groundwater and movement of groundwater. And that's why the caps are constructed to control that flux, the flux of chemicals from contaminated sediments below a cap, through a cap to the river. If we treat all of the material, there won't be anything left for that groundwater flux process to carry. In fact, the material that we'll be leaving behind won't have significant flux in any regard, whether or not there's contamination. So it provides a much more stable and solid outcome from a chemical transportation perspective. If you look back on the third bullet on the left, as I mentioned earlier, there's considerable work that's required to address slope stability issues, the structural issues that we have, and also the seismic risks. And we can manage those through design. There are other parties who are going to be using dredging and capping in Portland Harbor. But for Gasco, we have particularly steep slopes. We have complex dock structures, and the contamination itself lends itself to this type of method. And so by using the ISS approach, we can eliminate those slope stability issues, we can eliminate the structural issues, and we result in a cleanup with better seismic resiliency. Finally, when we look at the dredge and cap alternative, the habitat that gets left behind is limited. We're required to maintain a 3-to-1 slope, and given all of the structural issues we're already dealing with the dredge and cap alternative, that's the best we can come up with for a habitat. With the ISS solution, the final slope of the surface, all the way from the riverbank out to the navigation channel, can be created into any configuration that provides an optimal habitat. And so we'll be working with EPA and its partners to determine what that actually looks like. But it gives us much more flexibility and control over the post-construction surface than we have with dredging and capping. And as I mentioned earlier, because we're removing less material from the river, we also have to transport less material. And again, here I'm comparing only the technologies that are applied in those 3 zones I was talking about earlier, the intermediate zone, the shallow zone, and the riverbank. So we're basically switching dredging and capping in those areas with ISS, but we're still dredging the navigation channel portion of the river. And I'm going to show you what that looks like very soon. Next slide, please. So the next slide is a map, and before I get there, I wanted to just share with you that when we talked with EPA about this alternative, one of the things that we wanted to be sure of collectively was that the remedy itself addressed all of the pathways and all of the risks that we've identified through this 20-year Superfund process. And we believe that what I'm about to show you will do that. We have to test things, as Hunter said. There's treatability studies that we have to do before we can be 100% sure exactly what this design will look like. And we have to do some pilot testing, which we've already committed to doing. But the next slide shows you the vision. So next slide, please. So if we start out in the river and work our way towards the land, the darker blue area is what I was saying before. That's all dredging. We would dredge all the way down to relic exceedances, and because all the contamination would be removed to the cleanup levels, no capping would be required. Everything from that point inward to the shoreline would be treated, and we would be treating that using the in situ stabilization method. And so you can see here that the entire footprint of the cleanup area gets addressed all the way down to the action levels in the rod. Next slide, please. In cross section, this is what the cleanup looks like. So again, on the left-hand side of this figure is the riverbank. On the right-hand side of this figure, the riverbank slopes to the navigation channel, and you can see a portion of the navigation channel shown there. So the in situ treatment technology will be applied everywhere from the riverbank out to the edge of the navigation channel, and then dredging beyond that. And you can see within the green areas shown on this representation, some of those orange dotted areas, that's representative where we have those high concentration materials. So whether we have shallow concentrations of say tar and oil, or those are present at depth, the ISS method gets both, regardless of the thickness that we have to go through in order to make the treatment work. Next slide, please. So that was a very quick and brief overview of a pretty complicated technology that we are planning on using. And it really is, we think, a more protective outcome for a site like the Gasco area. But I'm very interested in hearing any questions from the group on this.